Hi, this is Paula Januszkiewicz. Welcome to another episode of Secure Hacks Weekly. This time we're going to be talking about memory dump analysis, also pretty interesting subject. Here's a little story first. I was doing a pen test in the medical company and I was talking with administrator to make sure that I know where I'm in, how the infrastructure looks like. And that discussion was already like 2 hours long. And what he asked me is like, hey, do you want a cup of coffee or tea? And then he stood up and he went away. And obviously I didn't want any coffee and tea because I was actually looking for one situation to happen is that he doesn't lock his desktop. So he didn't. So what I quickly did, I took my pen drive, I jumped in to his computer and I plugged it in and I performed a memory dump out of which I obviously was able to extract all the interesting juicy data and one of the things that I was able to get was his password. So my pen test started without really touching the infrastructure just because it's a little incident there. So lesson learned, what is really important to understand is that whatever works, it's always in the memory, whatever happens, it's always in the memory, and it would be fantastic so that we learn how to perform memory dumps in order to follow the incident response activities and also how to extract information from the memory so that we are able to get a little bit more insight about what was or is working in the operating system right now. In a 2 days episode, I will show you how to perform memory dump and how to, by using different kinds of tools, extract information from the memory dump. Okay, so let's get started. Okay guys, so you should see my screen right now and we're gonna learn first how to perform memory dump of the whole operating system's memory. And then we're going to learn how to perform memory dumps of the certain process and how to analyze it in both ways. Yeah? So let's first perform the memory dump of the full operating system. For that, let me go to my toolkit. So I will go to memory and then I got my toolkit here. And for that purpose, I will use the tool Dump It. This is a tool by Matthew Sish, and you're gonna find the link in the description below where you can download the tool. And it comes in many versions, so you will check out. But to be sincere, the reason why I'm using it, it's because it's the best and it's like the simplest way to perform memory dump of the whole operating system, and especially if you did not have your adventure with memory analysis, I think this is very convenient because the only thing you need to do is just to launch it. You need to be running the console as an administrator, or you just double click on a tool and then you elevate, and then it asks you if you would like to continue and perform the memory dump of the whole operating system, which I will in this case say no, because it's no fun in writing the big file into a disk, but in your case you say yes, and then you analyze that memory dump. I have already made a dump for the purpose of this video, so I will just say no. So this is how we are able to do it. One of the tools. There is a very good website, Forensic Wiki, and there is a list of tools that you can use for memory imaging, so you can always check out this if you are searching for some alternatives. Okay, so we've got that. The second thing is how to perform the memory dump of the process. And to be sincere, there are many ways to do it, starting from procdump, which is a very good tool which you can download from sysinternals.com, ending up with even Task Manager that I have opened here. I have it opened and I want to show you this because I would say as easy as possible for now, so that we are able to jump into memory analysis. Of course, any really version of Process Explorer, so you just right click on the particular process, yes, and then there's an option Create Dump. So this is another tool from sysinternals.com. And alternative, you've got also Process Hacker, the same story. Right click, create a dump file, and then you got it. So plenty of ways, yes. I will perform the Elsa's dump from Task Manager. Let's do it. So create a dump file, and I will copy the path that you're going to see in a second. So here we go. Let's do it. And I will copy the dump. This is this elsas.tmp, and I will copy the dump here to my Mimikatz folder. This is a tool that I was already mentioned before, a great tool by Benjamin Dolby. Basically, we have our own version in cooperation with Benjamin. This is the one that we made not recognizable by antivirus. But in this case, I will use it for memory analysis. Yeah, so we were working with this tool in the operating system and performing the different activities online on the active processes and so on. And right now I will just connect to the dump. So as you see, we don't need to use only debuggers to analyze memory. Sometimes it might be a dedicated tool just to extract a certain type of information from the dump, and that's it. So memory analysis can be endless, as we know, and it can be like super short. One thing for sure is that whatever works always, it's in the memory. So in the memory dumps, you can find a big amount of different kinds of data, different kinds of information. And when in this case we will run Mimikatz, we can do cqu LSA mini dump in order to connect to the memory dump, LSA ss.dmp, because I got it in the same folder. Here we go. And the next step is to do something that you may already know, which is secure LSA, logon, passwords, and then this information comes directly from the dump. And of course, we are able to spot over here different like username, password, and things like that. So, and users, passwords, hash, or as we should say, NT-hash or NTLM hash. There are different ways how this can be named. So here we go. So this is like a little extraction of the data from the process. Of course, whenever we are thinking about memory analysis of the whole operating system, I have here Python script, and in our case that's gonna be volatility, and we can use this tool in order to jump into the subject. It's very convenient when we configure it properly because it can give you a lot of information related to like what kind of processes we're running, what types of handles and what kind of handles, where for which process and so on. So which type of, for example, DLLs where, and so there's a lot of information that we can grab. But putting this in a technical frame, in order to set it up correctly, you need to, of course, download Python, and I would recommend 2.7x, so the newest version. And the reason why 32-bit, because well, there's a lot of different extensions that we need to be using for memory analysis, and a lot of them is available only in a 32-bit edition. That's why, of course, active Python, we need to just be comfortable when we work, and volatility itself 32-bit. And that is because there's also plenty of modules that are 32-bit only, so you just want to make sure that you've got the full functionality here. Of course, you can use it for analysis of the 64-bit operating system. That's all good. So let's do it. Yes, so we've got a volatility.py -f to specify the file, and my file with the dumps is in a D tools, and then I've got here dumps, and then I've got analyze.dmp. This is a dump that I made previously, and we need to specify here profile. And within this profile, we specify what kind of operating system that is. Sometimes we may not know. Then there is a possibility to check. There is an image info module which we can use to verify. But in this case, we know it's a Windows 7, in my case SP1, and then x64. Very good. And in order to get some information from the dump, let's say we want to list processes, so ps list. So very simple, and very quickly we're gonna get information about what kind of processes were running when we were performing this dump. But I want to show you something interesting here. So this is the beauty about memory, because whatever works, as we remember, it's in a memory. So we can spot here a list of processes, but this is not a complete list, because some of the processes, I don't like the word hidden, but because they are not showing up, then we could say that they are hidden. They are just not in front of our eyes. And these processes can be found by our analysis over here. So what we will do, instead of ps list, I will do ps scan. And that takes a little bit longer maybe, but at least we have here the process, a new one that wasn't before on the list. It's called malware.exe. So we can verify, just double check it wasn't before, but it wasn't. Let's see, let me show you. So this is this list over here. And as you see, malware.exe does not exist. But in the second type of command, it comes out. So why is that so? Well, the answer is maybe not very simple, but that is something that we call active process links. It is a list entry structure, part of the e-process structure. Well, in a normal language, means that process, in order to exist in Windows, needs to be designed in a certain way. One of the things that it needs to have, it's the indication where is it on the process list. So for example, this is how Process Explorer, Process Hacker, Task Manager and other tools list processes in Windows. So this is like a dual existence. So one process indicates on the previous one and the next one. Yes. So what I did in this operating system, I have modified that particular structure so that malware.exe, it's gone from the list. So in this particular case, the only way to show it is, for example, to get access to the handles of client-server runtime subsystem, which means that, well, if this is the guy that manages processes, he knows where that particular process is going to be, so we are able to spot it. Yeah, so because it works, it's in a memory. Okay, so the last thing that I wanted to show you is how we are able to extract files from memory. So let me clear the screen over here. And in this particular case, we will use a DLL List option. So let's do it. So I'm just gonna do, here we go, ps scan. So that's gonna be that one. I'm just gonna run this command, DLL List, and DLL List triple L, and DLL list.txt. Perfect. So in a second, we're going to have a full list of different DLLs loaded within the processes. So we can check what is inside. This is good. And what I will be interested in, let's say, in extraction of the event logs from memory. So what I need to search for, because we know that from the event log perspective, let me show you this one so that it's all nice and clear within the task manager, why not? We can go to services over here, and description, we can sort by the description. And what is the point is that we will be able to, well, find out over here the service. So this is a Windows event log. So it's an event log, a short name. And we can go to details, as you see. And what is selected here, highlighted, is the SVC host. But we've got many SVC hosts over here. So how do I know from the memory dump which SVC host was responsible for hosting event log? Well, that is actually very easy to check, since we know that WEVT SVC, it's a DLL that is representing this service. So we can jump over here and we can spot that this is indeed process ID 848. Perfect. So at that stage, the next thing that we will need to do is to dump files. Here we go. And within the dump files, we will specify that we would like to extract data from the process 848, which was our SVC host. And I will save everything in directory, let's say file handles that I have over here. Yeah, so this is the data extraction that's going to happen right now. It's case sensitive, so you need to use capital D. And what you see that is happening right now, it's the extraction of the logs. So it takes a little while. You always need to be patient with memory analysis. But what is important to understand here that these files, there is a like high probability that they will not be consistent. So sometimes you will need to work on them a little bit more in order to get the data extracted. Okay, so we got it. We can go to our file handles. We can list off what is happening over here, and we can take one of these files to try to open it. Yes, so let's choose something nice. Maybe this could be this file Windows operational, or maybe not that. Let's work. Why not? But let's choose something else. Maybe could be this one. Diagnostics performance operational EVTX. Yeah, so I will take this. Okay. So I got a file and we're gonna rename it to, well, the same one, but we will specify just EVTX, okay? So we got it, and let's try to open it. So I will just delete this. Yeah, and event viewer opens, and it's gonna take a little while because it tries to interpret it, and sometimes we manage to have it. Yeah, so sometimes it's okay. Sometimes this file opens and this is all good. But if we choose, for example, some other type of log, let me quickly choose it. It could be, for example, this one. Let's try. Yeah, so rename. And then I will rename it to EVTX. And then I will try to open it. Let's see if that works. Yeah, in this case, we can see that it was fine. So basically, let's find something that it's not working correctly. Yeah? So we were lucky here. We are very lucky. So let me find a file which might not be that super cool to open because it has a lot of different events. So I guess it could be something even diagnostics, or it could be as well something related with application log. It could be because there's like a lot of data. So let me choose something good here. So let's take another example. It's going to be rename, and maybe this one. So we've got EVTX and VACB, and we're going to rename it to EVTX. Yes. And let's try to open this one. EVTX, we got it. So let me open it one more time. Here we go. And that's what I wanted to show you. Sometimes we see that the file, event log like here, might be corrupted. So, well, let's say okay. And what we get, it doesn't open, yes, as we see. So what we will do in that stage, I'm just going to copy it into my toolkit to recover it. So we are copying it into D, Tools, Tools, TE, and then I got my demos and I got mem EVTX recovery in. Very good. So in the second console, over here, I am already in this folder. So let's go to in, and then dir, as you see, this is the only file that I've got. And I'm going to go to out, dir, and this is empty. Lovely. Let me clear the screen, and we're going to use our tool cqu.re recovery.exe, where we specify points of entry. So in folder, out, and we are recovering the file. So as you see, successfully recovered 17 records. So we can go into, not this one, but here, and to out, dir, we've got our file, and let's open it and let's see what happens. So for now, fingers crossed, because when the file is recovered, it should be all good with particular file. So this is this application EVTX that wasn't working, yes, and this is an application EVTX that is right now recovered. So sometimes we need to work a little bit harder on what we are able to extract from the memory. Okay guys, so what you have learned in this video is how to perform memory dumps, and also we have analyzed them from the system perspective and also from the process perspective. We could be talking about that for hours, so stay tuned because I'm super happy to prepare more videos where I will be talking about analysis from the different perspective. Okay, so I hope it was interesting for you. As you can see, a memory dump analysis, it's endless. It's a never-ending story. You can spend there like a couple of minutes or a couple of weeks, depending on the project and type of information that you want to extract. So if you guys have some questions and you are interested in particular things to be analyzed, just post them in the comments, and I will do my best to answer these questions and eventually record some new episodes with the answer to your questions later. Thank you so much.